All right, today we're finishing up with the Section 3 notes, our second day in that series. We'll do examples 1 and 3 and 4, and I'll skip over number 2 here for now. Let's take a look at what we have. Our goal is to try and write the equation of this hyperbola, and so we have to figure out whether we have a vertical axis or a horizontal axis. So here's a graph. Let's plot some points with these large numbers. Let's count by 2s to fit our points here on the scale that we have. So there's one vertex and the other is 2, 4, 6, 8, 9. There it is. So obviously we have a vertical axis in this case. So that means our center will be smack dab in the middle. There it is. So that's located at 4, 5. So h is 4, k is 5. The distance from center to vertex, that's the value of a. So that's a length of 4. So 2, 4. And so we got that from the vertices. Now for the foci at 4, 0. And 410, that distance from center to focus will be the value of c. So that's a distance of 5. There it is. So what that means for us is we can use our Pythagorean theorem to find the b. So 5 squared equals 4 squared plus b squared. 25 equals 16 plus b squared. So that's a 9. And it works out nicely to be exactly 3. All right, so we have all the values. And now we can write the equation. So again, with the vertical axis, we want the y in front, just like the y-axis is vertical. So we want y minus k. So y minus the 5, quantity squared, over the a squared, minus x minus the h. So x minus 4, quantity squared, over the b squared. And that's pretty much it. We got it done. Now let's go a little bit farther. Let's talk about writing the equations of those slanted asymptotes. All right, so this is a little bit of a review because this is what we did on the day 1 section of the notes. Remember, we want to create this box here, and the vertices are creating the upper and lower boundaries, and then the value of b will create the left and the right boundaries. So 3 units to the left of the center and to the right of the center. And what we're doing here is we're really looking to see, okay, so this would be where the slanted asymptote goes. What we're really trying to do is we're trying to figure out this slope, right? And so when we do the rise over run, we're trying to figure out, is it a over b or is it b over a? So we're going up to the vertex. That means that's the distance of 4. That's the a. And then we're running to the right, and that's the distance of b, which is the 3. So in other words, the slope is 4/3. All right, so y equals plus or minus 4/3, x minus 4, and then the k value plus 5. So that's the equation of our 2 asymptotes. All right, so we're taking a look at 3 and 4. These are a little bit harder, and so we have a bit more algebra in these 2 problems. We want to take a look at this, and we'll try to fit in our work here in the space as best we can. So we're not actually plotting the hyperbola, but we will draw a sketch, again, just to orient which direction our axis is placed and pick up on some other values. So let's go ahead and plot these points. I'll just draw a little mini diagram here just to kind of get a reference of where things are located. So 0, 0, there's one vertex, and then here's the other at 0, 4. Right, and so that means we obviously have a vertical axis, just like last time. So our center will be right there in the middle, 0, 2. So now we know h is 0, k is 2. Distance from center to vertex is a, which is also 2. And now it seems we're a little bit stuck because we don't have information about the focus, which means we don't have a c, which means we can't use the Pythagorean theorem to find the missing value of b. We need another approach instead. So this is actually giving us an x-coordinate and a y-coordinate. And when we have our equation, there is an x and there is a y. So we're going to be plugging this ordered pair in for x and y, along with the center for the h and the k. And that way we can solve for our missing variable using the equation itself. Right? So let me start over here on the left-hand side, and we'll work into the next column. So this is my equation. Again, it's a vertical axis, so y in front. So it's y minus k quantity squared over the a squared minus x minus h squared over the b squared, and that equals 1. All right, so our y is the 5. and the k is 2. The value of a is 2, so when we square that, that'll be a denominator of 4. X is the root 5. We're subtracting the h, which is the 0, and that'll be squared as well. So this is what we don't have. We don't have that, so the b is our variable that we're trying to solve for. This equals 1. So we will simplify this here. We have on top 3 squared is 9, so we have 9/4 minus, so the square and the square root cancel out. So it'll turn into a normal 5 over the b squared. That's what we're trying to solve for. So let's subtract 9/4 from each side. So negative 5 b squared equals 1 minus the 9/4. And of course, we need to create a common denominator. So it's 4/4 minus 9/4. Notice what happens here. In this particular case, we get negative 5 over 4. Right? Notice the numerators are exactly the same. That means the denominators will be equivalent as well. Now, technically, this is a proportion, so we would actually be cross-multiplying to get that answer, but this is the pattern. We can pick up on this as a shortcut. The numerators are the same, the ratios are the same, so that means the denominators must be equivalent as well. So b is 2. Now we can write the equation of our hyperbola. Oops, I wanted the y in front. Let me change that. So y minus 2, that's the value of k, quantity squared over a squared, that's 4, minus x minus h, which is 0, so that's just an x squared, over another 4, and that equals 1. There's the final answer. All right. Notice you can have the denominators, that's the same. You can have a and b the same, that's fine. And now for number 4. Again, we'll start off with a bit of a sketch, and we have an interesting combination of information. We have a pair of foci, and we have these asymptotes, which will give us a slope. But again, we have to figure out the a and the b as well, just to write the equation. So just to orient ourselves here, here is a little bit of a sketch with a focus at 0,8 as well as 0, -8. So we can see our center is right there at the origin, so we know h and k. The distance from center to focus is the c. So we know c is 8, but that's not very helpful yet. We want both a and b to write the equation, so we're still missing a lot of information here. So now let's bring in this next part. Now, we would normally be talking about the slope when we're looking at the box. And usually we have to have that dimension, the a and the b, to create the box. So what I'm doing here in this problem is I'm going to draw the box just representing the dimensions without actually knowing what the dimensions are. So we have to figure out, is our slope a over b or is it b over a? So I can use a picture to help me kind of work our way through it. Because we know we have a vertical axis, that means the vertices must also be on this axis. So I don't really know where the vertex is, but it's going to be somewhere between the center and the focus. What that means is this dimension is a. So if we create this box, for example, and we have this slanted asymptote with that slope of 4, what we're saying is we're going up 4 and over 1. Now I haven't drawn that to scale, but notice this is the value of a. So we're going up a, and then we're going over b. So what we have here represented is the slope as a over b. Not b over a, in other words. Because we went up 4, we went up a. Because it's the distance of a from the center to the vertex, so we have to go up a. That means our slope is 4 over 1. And look at that. Now you have to be careful here. Don't just assume a equals 4 and b equals 1, because it's not. Remember, this is the reduced ratio. Maybe a is 8 and b is 2, right? Maybe it's 16 and 4. Maybe it's some other value that would reduce to 4 over 1. So you can't just assume a is 4 and b is 1. No, instead we have to cross multiply. And what we have instead is an equation that relates a and b. All right? That by itself isn't going to get us very far. We need yet another equation. So let's bring in the Pythagorean Theorem. So I'm going to move over here into this space. C squared equals a squared plus b squared. We do have a number for c, which is the 8. We don't have the number for a, but we do have an expression. A can be thought of as being equal to 4b. So we're doing a substitution. that has to be squared, and there's b squared. Essentially, we have a system of equations. We have two equations with two variables. We're substituting one into the other to eliminate a variable, and this is how we'll solve for b. So 64 equals 16b plus 1b, 16b squared plus 1b squared. So that's 17b squared. That means b squared is this funny-looking fraction of 64 over 17. That means b is 8 over root 17. Normally we would rationalize the denominator, but we're not here so that it's easier to build the equation of the hyperbola that we will need, and we'll need the b squared, or the b in just a moment. Okay, once you get the answer, what do? You go back here and plug it back in. So since there's not a whole lot of working space here, I'm just going to carry on right over here. So a equals 4 times the value of b. Now we know what the value of b is, 8 over root 17. That means my a is 32 over root 17. Odd-looking fractions, but if you compare the value of a with the value of b, you will discover that it is in this ratio of 4 to 1. Now let's square this so that we can get it ready for our equation. So you square the top, we get 1024, and the bottom is 17. Now we're ready for our equation. So it's, again, another example of a vertical axis, so y comes in front. The centers are at 0. So we have a y squared over the a squared. There's the a squared. 1024 over 17 minus the x squared over the b squared. There's the b squared of 64 over 17. And then that equals 1. And there it is, just on the edge of the paper. We fit that in. There's our result. So we're finishing up with the next page, which is to say we're going to be taking a look at patterns here and identifying what kind of a conic section we have without going through the work of completing the square to see if it, matches a particular standard form. So we might have all different kinds of combinations of terms, and what really matters is the leading coefficient on the x squared and the y squared term, and whether you have a matching sign, if they're both positive or if one of them is negative. We can pretty much ignore all of the others. So for example, on a circle, we will have the same coefficients for a and c, because that represents the major axis is the same as the minor axis. We don't call it major minor axis on a circle, we just say it has a radius. It's the ellipse that has a major and minor axis. So that means the a will not equal the c. They'll be different numbers. And because they're both positive, if you were to multiply them together, you should get something that's greater than 0. Positive, in other words. The hyperbola, these are also different values, but this time with a minus sign right here. So if you were to multiply the coefficients together, you should get a negative result because you'd have a negative coefficient. The parabola is the only one that's really different in this case. Remember, with the parabola, the standard form is either x squared equals 4 times p times y, or it's y squared equals 4 times p times x. In other words, you only have an x squared or a y squared. You don't have both. And that's what this is saying here. One of those terms are missing. All right, so let's see if we can identify those patterns in this last set of examples. So we're looking at the x squared and the y squared. We want to know, are the numbers the same? If they're the same, it would be a circle. They are not the same, and you see the minus sign right there, so that's the hyperbola. Number 2, I have a y squared term, but there is no x squared term, so that's the parabola. Number 3, I have an x squared and a y squared. Those coefficients are different, so it's not a circle. We have the plus sign, therefore it's an ellipse. Number 4, I have an x squared term, but I don't have a y squared term. That's a parabola. And lastly, here's my x squared and y squared terms. Coefficients are the same, and it's positive, so that's our circle.